Welcome back to Math with Rhyme or Reason. Today we're going to complete the radical equation series by solving actual radical equations. So with this one I'm actually going to make some notes because there are some very specific things that you have to look out for. So when you are solving radical equations, the first thing you need to do is isolate the radical. Now sometimes in the very beginning these will be already isolated, and I'll show you what I mean. Then the next thing you want to do is square both sides. What that does is it undoes the radical because squaring and square rooting are inverse functions. And again, I'll show that a little more specifically in a minute. Then you solve. Often this is accomplished by factoring because you'll usually have a quadratic. Sometimes, of course, you can use the quadratic formula or anything else if it's not nice numbers, as in not a fraction or an integer. And then, and this is important, make sure you check your solutions back into the original equation. An extraneous root is what happens when you solve correctly and algebraically correctly, but the solution does not make the original equation true. And I'll do a couple examples of those too. If they're extraneous, they aren't solutions to the equation. There's also a little bit of a way you can check if you've just made a mathematical error or if you actually have an extraneous root. It's not 100%, but it's a rule of thumb, and I'll show you that as well. But make sure you do this step. Now, for the purpose of this video, I'm also not going to worry too much about the domain values. That is, I'm going to assume I'm not square rooting negative numbers. That is, I'm not going to restrict my x values so that that works. And that's mostly because I'm dealing with equations versus inequations, which we'll talk about later in another video. Okay, so let's start with some nice easy examples. Now these go from easy to difficult in really quick order. So we're going to start with some easy ones and then we'll work our way up. So the first one I'm going to do is okay, on this one, the radical is already isolated, so we don't need to worry about that step. So what I'm going to do is square both sides. Like I said, I wanted to take a minute to explain the math behind why this is a true statement and why this undoes the square root. So remember in the last video, we talked about the fact that radicals are fractional exponents. So I could rewrite the left-hand side to look like that. When you have a power raised to a power, you multiply your exponents. In other words, 1/2 times 2 is 1, and so you get back your 2x minus 3 to the 1th, as it were. In other words, effectively, I have eliminated the square root sign. Okay, making sure I square this side as well. All right, now this one's linear, so it's quite easy to solve. We're going to add 3 to both sides. That gives me 2x equals 28. I'm going to divide both sides by 2. I get x equals 14. All right. So now I'm going to check it back into the original in the blue equation before I squared anything. So I'll do that over on this side. So 2 times 14 is 28, minus 3, square rooted, equals 5. When we are square rooting, we assume the principal square root, that is 28 minus 3 is 25. The square root of 25 is 5. If I want you to worry about the positive and negative, I have to tell you that. That is, I would have to put a plus or minus there. Since there is no plus or minus there, we assume the positive square root or the principal square root. In other words, we assume that the square root of 25 is 5, not plus or minus 5. So 14 is a legitimate answer. It works back in the original equation, and everything is good. Let's try another. All right. Now this one, yeah, it's still got the 1 square root, but we're going to add. Okay, and I spaced it out. Just going to make sure I wrote it right. Yep. I spaced it out just to show you clearly that the 2x plus 1 is under the square root and the 7 is not under the square root. So the first thing I have to do is isolate the radical. I'm going to subtract 7 from both sides. When I do that, I get the square root of 2x plus 1 equaling x minus 7. Now I'm going to square both sides. Now when I do that, this is probably the most common error that my students make, and I'll show you what it is in just 1 second. On the left-hand side, like I showed in the previous example, the square root and square undo each other. They're inverse functions, and so I get back 2x plus 1. On the right-hand side is where the issues tend to happen. This is not x squared plus 49. Remember that when you're squaring it, you have to FOIL it out. So in order to not forget that, it may be useful for you to write down x minus 7 times x minus 7 and to FOIL that whole thing out. So if you do that, you get your x squared minus 7x minus 7x, that's outside inside, right, is minus 14x. Negative 7 times negative 7 is plus 49. All right, now I'm going to get everything on one side so that I can solve it. This will be a quadratic, so I'll probably have to factor it or use the quadratic formula. Now, some of you like to move everything onto the left-hand side. That's fine too. It's just I like my leading coefficient and my leading term to be positive. It's a personal thing. So I'm going to subtract 2x minus 1 on both sides in order to keep this guy positive. So then I'll have 0 on this side. I have x squared. Subtracting 2x gives me negative 16x. Subtracting the 1 is plus 48. So this one is going to factor for me. I need two numbers that multiply to 48, add to negative 16. My two numbers are 12 and 4. So x minus 12, x minus 4. If you need a little review on factoring, you can go back to my factoring videos and review that. Now, when you are solving these, remember what this means. You have two numbers that are multiplying to equal 0. That means either this bracket equals 0 and or this bracket equals 0. If this bracket equals 0, then x equals 12. Because 12 minus 12 is 0. If this bracket equals 0, then x is 4. Because again, 4 minus 4 equals 0. So when you are solving by factoring, remember what you're doing. You're finding two numbers that multiply to 0. At least one of them must be 0. By the way, when you're solving quadratics, that's why you have to make it equal 0. Because if you have two numbers multiplying to anything except 0, you have an infinite number of solutions, and that's going to be tough to solve. So you want to make sure you set it equal to 0 every time. That means by necessity, one or both of the brackets has to be 0, and therefore x is 12 or 4. Let's plug them back into the original and make sure they work. So I'm going to use the 12 first. 2 times 12 is 24, plus 1 is the square root of 25, plus 7 equals 12. So 5 plus 7 is 12, and that one's fine. Okay, and I'm going to check the 4 as well. So 4 times 2 is 8, plus 1 is the square root of 9, plus 7 equals 4. So 3 plus 7 equals 4, not true. Okay, so this one is extraneous, and therefore it's not a solution. The only solution for this equation is x equals 12. Now, just a quick note about how to check if you have done the wrong algebra entirely or if you have an extraneous root. Usually it's a negative. So for example, if this one was 3 minus 7 or negative 3 plus 7, you would get the 4, either negative 4 or positive 4. That almost guarantees that I didn't mess up the algebra, but that it's an extraneous root. If you end up with something like 12 equals 28, then you probably have messed up the algebra. Go back and figure it out. My guess is you've squared this incorrectly. All right, so like I said, it's a rule of thumb. It's not a for sure, but generally extraneous roots show up because you've lost a negative along the way when you squared things. Then you end up with positive versus negative issues. Okay. All right.